Hello again. Welcome to our second video lecture for the topic atoms. Again, like what I've said in our previous lecture, this lecture is or this video is intended only for electron configuration. Guys, please help me or please allow me not to show myself today in this video because I want to write, and having a hard time to write na yung screen ko ay maliit. So this time I will write so that we can understand on how are we going to do the electron configuration. Right? So let's proceed to our topic. Electron configuration is the arrangement of electrons in the extranuclear space. Okay? A description of the orbital of an atom or ion occupied by an element or by an electron rather is also another definition of electron configuration. We can also say that electron configuration is or electron configuration of an atom is the description of the orbitals that it occupies. Okay? The orbitals of all atoms are same, namely as 1s, 2s, 2p, 3s, 3p, and so on. Now we have what we call ground state electron configuration. What does it mean? Ground state electron configuration is the electron configuration of the lowest energy state of an atom. Right? We have three rules to follow on how are we going to do electron configuration. This is what I am telling you a while ago. No? We have the four shells, the 1, 2, 3, 4 shells, and the number of electrons it can hold. So shell 1 can only hold 2 electrons. Shell 2 can only hold 8 electrons. Shell 3 can only hold 18 electrons. And shell 4 can hold 32 electrons. This shell pertains to the valence electrons. Valence shell, rather. I repeat, these shells refers to the valence shell. Meaning to say, shell 1 can only contain 2, which is the lowest. Shell 2 can contain 8. How come that shell 2 can contain 8? We have the 1, 2s, and the 1 or the 3 2p's. The 2px, the 2py, and the 2pz. Later, you will find it out what I am saying. 3 shell can contain 18 because it can hold 1 3s, 3 3p, and 5 3d, which is approximately or equals to 18. While shell 4 can contain 1 4s, 3 4p, 5 4d, and 7 4f orbitals. Meaning to say, it can hold 32 electrons. And relative to their energies is the electrons in each cell, pataas po. From 1 to 4, nataas po ang kanilang energy. So, what are the three rules in electron configuration? Okay, rule number 1. Orbitals fill in the order of increasing number energy from lowest to highest for elements in the first 3 periods. The order is 1s, 2s, 2p, 3s, 3p, and 3d. Okay? So this is what is rule number 1. How about rule number 2? Each orbital can hold up to 2 electrons with spinning paired. This is true with orbital box diagram of our electron configuration. And later, I'm going to show to you what is this orbital box diagram. Yan. This is what we are telling a while ago. No? We concern primarily with the elements of the first, second, and third periods of the periodic table. Orbitals in these elements fill the orders 1s, 2s, 2p, 3s, 3p, and 3d. This is what is stated in rule number 1. Okay? When there is a set of orbitals of equals or equal energy, each orbital becomes half filled before all of them becomes completely filled. Okay? Take note that after the 1s and 2s orbital are filled, the fifth electron is put into the 2px orbital. In the 2py orbital, and 7 in the 2pz orbital. Electrons are placed into orbitals of equal energy using the same spin direction before pairing begins. Now, we have this. This is your Christmas tree. And very timely, Jose Marie Chan is looking at you. Since it's almost Christmas season, bare months, then we have here Jose Marie Chan. I know this is not the first time na nakita nyo ang diagram na ito. For the meantime, this will be your Christmas tree. And what is this Christmas tree is all about? This is the arrangement of our orbitals. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 4p, 5p rather, 6s, okay, 4f, 5d, 6p, 7s, 5f, 6d, 7p, 8s. Remember that S can hold 2 electrons. 2 electrons lang. Tandaan mo. P can hold 6 electrons. Take note, 6 daw. D can hold 10. Oh, D 10. Sir, bingo ba yan? Hindi. Tandaan mo, D can hold up to 10 electrons. And F, the highest, can contain 14 electrons. So let's try. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6, and 8s2. Tandaan mo, kantahin mo, nang di mo malimutan. Ako ang iyong bangungot, kaya huwag mo siyang kalilimutan. Tandaan mo siya para alam mo kung paano ka maggagawa ng iyong electron configuration. Example, give the ground electron configuration condensed of the following elements. Given We have here argon 18, neon 10, sodium 11, and phosphorus 15. So now, let's have it. Let's start with argon 18. So how are we going to do that? Tandaan mo, 1s2, 2s2, 2p6, 3s2, 3p6. That is the condensed grounded electron configuration of argon. So I will write argon 1s2, 2s2, 2p6, 3s2, 3p6. 2 plus 2 is 4. Plus 6 is 10. Plus 2 is 12. Plus 6 is 18. Electron. Neon 10. How are we going to give, or what is the condensed electron configuration of neon 10? So let's start. 1s2, 2s2, 2p6. Are we going to stop here? Of course. Why? Because we've already reached the 10. 6 plus 2 is 8 plus 2 is 10. That is the electron configuration of neon 10. How about sodium 11? 1s2, 2s2, 2p6. 3s? Don't say 2, because if that will be 2, it is not our sodium. It will become our magnesium. Remember that S can hold up to 2 electrons. But if you have to cut it, then just simply give it 1 electron so that we will satisfy what is the need. 1s2, 2s2, 2p6, 3s1. Next, how about phosphorus 15? 1s2, 2s2, 2p6. Are we going to stop here? No. Continue. 3s. Sir, this time, 1 pa din ba? No. Because what we need is 15. So if this is only 1, kukulangin tayo. So 3s, 2. Since S can hold 2 orbital. Then 3p. This time, we only have 3p3. So that we have 15. Ngumingiti ka sa oras na ito kasi alam kong naiintindihan mo ako. Naaalala mo yung teacher mo, yung chemistry nung high school ka. Na galit sa'yo kapag hindi mo na enumerate ang 1s2, 2s2, 2p6, 3s2, 3p6 sa unahan. Tama ba? Natatawa ka kasi totoo. Okay? So yan ang condensed electron configuration. So puntahan naman natin yung other way on how are we going to do electron configuration. And that is the orbital box diagram. Orbital box diagram is a representation of the pairing of our electrons in each shell. Okay? I repeat, it illustrates the rule used in electron configuration. Okay, so example, we have here 1s2, okay, 1s2. Why 2? We have here one arrow going up and one arrow going down. This is a representation of our electrons. All orbitals of the equal energy have at least one electron before them is filled. Okay? So 1s will become 1s2, 2s2, 2p. This time, yung 2p natin is 2p2. And according to our rule, what is said in our rule, before the next box ay makomplete, before the next set of orbitals becomes complete, then the electrons should be distributed equally. So instead of having here another arrow which represents the electron, then might as well let's give the electron first to the sub p, which is the 2py. So how about the 2pz? We only have 2, 4, 6 electrons. And how are we going to put it? Leave it blank. Okay? So this is the expanded electron configuration. 1s2, 2s2, 2px1. This is your 2px1. And this is your 2py1. You only have one electrons here. You only have one electron here. So that is the expanded. How about the condensed? Instead of saying 1s2, 2s2, 2px1, 2py1, we can say that 1s2, 2s2, 2p2 is the electron configuration for carbon 6. Okay? So, using the same example that we had in the first or in the previous slide, let's show the electron configuration of argon. So sabi natin, argon 18. Argon 18 is 1s2, 2s2, 2p6, 3s2, 3p6. So, what will be our box or orbital box diagram? You have here a box for 1s, a box for 2s, a box for 2px, a box for 2py, a box for 2pz, a box for 3s, a box for 3px, another box for 3py, and last, a box for 3pz. Alright, so 1s. Ang 1s natin have two electrons. 1, 2. 2s. 1, 2. Yung 2p natin, this is our 2p. We have 6 electrons. So we will distribute the 6 electrons in the 3 box. 1, 2, 3, 4, 5, 6. This is now our 2p. How about the 3s? We have 2 electrons. So we have one arrow up, one arrow down. Next, 3p. This is now our 3p. So how are we going to do it? 3 I'm sorry. Why am I writing 3p? Sorry guys. I supposed to write the electron represented by arrow. So we have 6 now electrons, no, on the outermost shell. 1, 2, 3, 4, 5, 6. There you have it. This is now the box diagram or box orbital diagram. This is the condensed electron configuration. Okay, so how about the expanded? So if you're going to take a look, expanded is expressed in this way. So let's do it. So we have 1s2, 2s2, 2px2, 2py2, 2pz2, 3s, 3px2, 3py2, and 3pz2. The box, the condensed, and the expanded. This one represents this one. This one represents this one. I hope you can follow. Now, let's try another example. Okay? Another example. Yung pong ating uh, aluminum. Okay? Aluminum 13. So let's have the electron configuration, the condensed. Okay, I will write here condensed. So what will be the electron configuration of aluminum 13? That will be 1s2, 2s2, 2p6, and 3s2, and we have 3p1. Bakit 1? 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 1 is 13. So we have 1 electron on the outermost shell. What will be our box diagram? 1s, 2s, 2px, 2pz, 2py, 3s, 3px, 3py, 3pz. How many electrons do we have on S? 1s, 2. 1, 2. On 2s, 2. 1, 2. On 2p, we have 6. Distribute it first. 1, 2, 3, 4, 5, 6. 3s, 2. 1, 2. 3p, we only have 1. 1. Here, wala. Here, wala. This is now our box diagram. How about the expanded one? So we have 1s2, 2s2, 2px2, 2pz2, 2py2, 3s2, 3px1, and that is the end. Okay? Next is, we have the Nobel Gas Notation. What is this all about? Okay? Nobel Gas Notation or Nobel Gas Notation is an alternative way of writing ground state electron configuration using the symbol of Nobel gas, immediately proceeding to the particular atom to indicate the electron configuration of the shell or of the field of the shell. Okay? So halimbawa po ulit tayo. Puntahan ulit natin si argon. Argon 18. O, ibigay ulit natin ang condense. Electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6. How about the box? For 1s, for 2s, 2px, for 2py, for 2pz. Bakit yung box ko palaki ng palaki? For 3s rather, and for 3px, 3py, and 3pz. All right? Down, up, down, up, down, up, down. Ay, sorry. Ito naman to, right? So, let's do it. Yan. Again, expanded. 1s2, 2s2, 2px2, 2py2, 2pj2, 3s2, 3px2, 3py2, and 3pj2. Now, how are we going to give the Nobel Gas Notation? The first thing to do, the first thing to remember in Nobel Gas Notation is to take note the nearest Nobel gas to our electron, to our element. And in this case, if you're going to take a look in your periodic table, the nearest, no? The nearest Nobel gas is neon, Ne. Oh, by the way, what is the electron configuration of neon? No? The electron configuration of neon is 1s2, 2s2, 2p6. So we're going to stop here. We're going to stop here na. Instead of writing 1s2, 2s2, 2p6 in Nobel gas notation, we're going to write it as Ne, neon, plus this, 3s2 and 3p6. Okay? Sir, how come? How come? This is already 10. 1s2, 2s2, 2p6. Just add it. So instead of punishing yourself of writing 1s2, 2s2, 2p6, then you can write Ne, 3s2, 3p6. Another example for those who are still confused. We have here, ano ba, Mark? We have here fluorine, 9. So 1s2, 2s2, 2p, 2p what? 2p5. So 5, 6, 7, 8, 9. Okay. So what will be the Nobel gas notation? The Nobel gas of notation is one. What is the nearest Nobel gas to fluorine? Take a look in your periodic table. 5, 4, 3, 2, 1. Correct. Helium. No? Helium is the nearest Nobel gas. So helium, ano yung ating electron configuration kay helium? 1s2. So instead of saying 1s2, then we can write fluorine 9 as helium 2s2, 2s2, 2p5. Okay. Another example we have here, magnesium. So 1s2, 2s2, 2p6, 3s2, right? So again, this is the electron configuration of neon. So instead of saying 1s2, 2s2, 2p6, then simply we can say that magnesium 12 is equals to neon 3s2. And that is our Nobel gas notation. That is how you're going to do your electron configuration. I hope you learned. I hope you recall the concept of electron configuration.